In this video, we want to talk about how to use the law of sines to solve a simple AAS case. By AAS, I mean you're given two angle measurements and the side length that's not between them. So, as is custom with most problems of this nature, you really want to start by sketching a picture. Sketch any triangle. Honestly, it doesn't matter what it looks like. It doesn't need to be remotely to scale in any way. Just label it A, B, and C. That's our customary letters here. And as you start to fill in information, what you want to keep in mind is that, especially when you get to this C and little c, the capital C will always represent an angle, and the lowercase c will represent the side length opposite from it. So angle C and little c will be opposite of each other. Now let's get started solving. When it comes to solving a triangle, whenever you're given two angles, obviously it's really easy to start by finding the third angle. So I'm just going to recommend you do that all the time. So angle A is 180 minus the two sides that you have. So 130 plus 35. So that's pretty straightforward, and you get 15 degrees for the last angle. So that should definitely be your starting point, is figuring out all the angles when you're given two of them, of course. Other instances you might not be able to do that, but whenever you can, that's the easy place to start. Now, what comes next is you got to set up the law of sines and solve for what's going to end up being little a and little b. So what you'll want to do, what I'm recommending that you do, is writing out the full length of the law of sines. Correct that real quick. And as you continue writing out your whole three ratios of the law of sines, you'll see pretty quickly that it really lets you know how to proceed. So for instance, we know we need to solve for A, and we've got a fraction with A, a full fraction here, so we'll put these two together and solve for A. Then we'll kind of ignore this being here, and we'll do this as the proportion to be solved. So do it one at a time, and it doesn't really matter what order you go in. I'll go in alphabetic order, so I'll say A over the sine of 15 is equal to 15 over the sine of 30. And I'll solve that piece, cross multiply this one, or just multiply both sides by sine of 15. The algebra that you use is really user defined. So I'm just going to multiply both sides by the sine of 15 here. And you get, we'll just go to our calculator and do 15 divided by the sine of 130 times the sine of 15. Pull the calculator here. So we'll do 15 times, divided by the sine of 130. By the way, make sure you're in degree mode, which I am. So 15 divided by the sine of 130 times the sine of 15. And that should give you your answer for little a. We get 5.06. Our standard rounding will be to 1/10. That'll be plenty accurate enough for our intentions here. So a is equal to 5.1. I like to write it into the actual diagram just for completion's sake. And now I can deal with this portion of it. Same exact algebraic procedures. Multiply both sides by sine of 35 in this particular case. So I'm just going to go and do that directly on the calculator. Let's pull up our calculator, and we'll do 15 divided by sine of 130, same as before, but this time we'll multiply by the sine of 35. And hopefully got our response. Yeah, 11.2. Seems pretty accurate to me. 11.2 for B. And like I said, I like to write it in the context here because at the end of a law of science problem like this, it is a good idea to keep things in your mind about being reasonable. In other words, think back to prior knowledge. 130 is obviously the biggest angle in this triangle. Opposite the longest side, absolutely it is. The smallest angle is opposite the largest side, absolutely. So a couple things that you might want to keep in mind when checking your answer for reasonableness. First of all, the triangle inequality always says that if this is C, this would be little a, and this would be little b. The sum of the two smaller sides has to be bigger than the last side. You can write that inequality either way, but the sum of any two sides has to be bigger than the last side. In other words, you couldn't have like 100 and a 2 over here and a 1 over here. That's called the triangle inequality. The two smaller sides have to add up to be bigger than the last side. So 5.1 and 11.2, that would be 16.3, definitely bigger than that. And then there's an intimate relationship between the sides and the angles. In other words, in this picture, just assume for a second it's drawn to scale. Angle C is the biggest, as I said earlier. The side opposite the biggest angle has to be the longest side, so little c is the longest. And then the other thing to keep in mind is little b, angle B was the smallest. And that went along with little b being the shortest. So those are some reasonableness checks that you can always consider when you're solving triangles. And anything that contradicts any previous knowledge can be considered and useful when solving triangles.